Hi, welcome back. Once again, I'm welcoming you all to this beautiful online learning platform, An Academy. An Academy is the India's largest online learning platform. So once again, I am welcoming you all to this beautiful online learning platform. Now we are happy to announce that An Academy is going to providing online training for GATE and engineering service exams. Online training for GATE and engineering service exams with India's top educators. About myself, I G Venkata. I have 16 plus years of teaching experience. So far I mentored more than 60,000 students for their GATE examination. At present, I am pursuing PhD from JNTU Kakinada, and my specialization is VLSI design. Now, here we check first how to get an Academy learning app into your device. Just go to Play Store, type An Academy, and it will show the An Academy learning app like this. An Academy learning app like this, and by clicking on this install button, it will install the An Academy learning app into your device. Now, first of all, you should know what you get by joining this An Academy. What you will get. First and foremost thing is daily live classes. Next, structured courses, live tests and quizzes. Next, unlimited access. What it is? What is a daily live class? See, here every day you have an online class. The intention behind to conduct online class and every day is to keep the student in touch with the subject. Always to keep the student in touch with the subject. With that intention we started this. Okay. After that, here during the live class you can chat with your educator, you can engage in discussions, you can ask your doubts, and you can answer the polls. So you can do all these things while class is going on. That is about your daily live classes. After that, structured courses. See, whatever the course here we have, all the courses are structured in line with your exam syllabus. All the courses are structured in line with your exam syllabus. Then once it is updated syllabus. Now once your syllabus is placed in a proper order, in a proper way, then it is very easy to the students to continue his preparation. From that, it is very easy to first which subject has to prepare, in that subject which topic has to cover first, after that which one, because subject to subject and topic to topic there is a connection. To maintain that connection, if you prepare, if you continue your preparation with that connection, then it is very easy to the student. So we will provide that data. With a proper order we place everything. After that, live tests and quizzes. Live tests and quizzes. See, after completion of your preparation, you can evaluate your preparation with our regular mock tests and quizzes. You can evaluate your preparation with our regular mock tests and quizzes and get the detailed analysis on your performance. And get the detailed analysis on your performance. So you can evaluate your preparation. After completion of your preparation, you can evaluate the level of how much level you complete your preparation for topic by writing our regular mock tests and quizzes. After completing the writing the tests and quizzes, we will give the detailed analysis on your performance in that. Okay. And after that, structured courses. In this, all our courses are structured in line with your exam syllabus over already. It is next, unlimited access. Here you get 1-to-1 subscription. So once you get one subscription, You can get access to all our live and recorded courses to watch from the comfort of any of your devices. Comfort of any of your devices. Okay. So once you get one subscription, you can get your access to all our live and recorded courses, and you can watch it from comfort of any of your device. That means you can use either laptop, desktop, mobile or tab, whatever it is, whatever the device you can use, choice is yours. Next, there are two plans, two subscriptions, iconic subscription as well as plus subscription. Plus subscription is the basic subscription. In plus subscription, just before what I was discussed, daily live classes, structured courses, live tests and quizzes, and unlimited access. Unlimited access. Okay, all these things you get in plus subscription. In plus subscription, you get all these things. Next, iconic subscription. In iconic subscription, first of all, you get what are the benefits got by the plus subscriber. You get all these benefits. You get all these benefits. In addition to that, you get personal coach, mains question and answer practice, as well as study tracker. See this, personal coach. Now, in this personal coach, sorry for delay. Now, so you get a personal coach. So what it is? Here you get one-on-one guidance from top exam expert. From top exam experts. You get one-on-one guidance from top exam experts. He is acting as your personal coach. Okay, and once you've written some exam or once you completed one quiz, based on your performance in that, they will prepare proper study plan and respect to study material they will provide to you. By following those two, you get the success in your examinations. At the same time, you can evaluate your progress in bi-weekly reviews with your personal coach. So you can evaluate your progress in bi-weekly reviews with your personal coach. For that, you need to participate in study tracker plan and study booster workshops. By participating in these two, you get that. Okay. Next, mains question and answer practice. Mains question and answer practice. Here, you can strengthen your mains answer writing through regular practice. See, in ESE, you need to attempt a mains paper. Okay, in that mains paper, you need to answer the descriptive questions. Now, how to answer those descriptive questions is, see, here you can strengthen your mains answer writing through regular practice. Regular practice is required for that. So, in that, you can continue your evaluation and personalized feedback. That means, once you've written the exam, once you answer the questions, we will evaluate it and we will give the personalized feedback to you. That is the mains question and answer practice. So these are the additional things you get in iconic subscription compared to plus subscriber. Now, see, So navigate. So your gate to crack the GATE exam. Navigate your gateway to crack the GATE. So this program is for mechanical, civil, computer science and IT, electrical and EC students. Okay, you can take the test and win the scholarship of worth 5 crores. This test is on May 23rd at 11 a.m. Okay, enroll now by using my code VROUT10. Okay. Next, see there is an academic scholarship test is going on in the month of May also. If your rank is in between 1 to 3, you get the complimentary an academy plus subscription for 1 year. And if your rank is 4 to 10, you get 75% off on an academy plus subscription for the tenure of your choice. And if your rank is 11 to 50, you get 50% off on your an academy plus subscription for the tenure of your choice. And for 51 to 100 rank, you get 25% off on your an academy plus subscription for the tenure of your choice. Now here winners will get the subscription of 6 months, 12 months. Now the subscription is a tenure is either 6 months, 12 months, that means 1 year, 1.5 years or 2 years. Choice is yours. Okay, you can take your choice. Next, now here the scholarship test is going to be next combat is on May 16th, coming Sunday. Don't forget, at 11 o'clock. Starts at 11 o'clock. Now what about this scholarship test is? It is the India's largest weekly competition for GATE, and you can assess your GATE preparation in 60 minutes and challenging original GATE questions curated by the best educators and take it live to compete with the best and super fast and fun with all India live leaderboard. See, compared to the topper where you are, to estimate that you need to write it a live, and in that for every comeback, that means for every answering of each and every question, based on your fast and accuracy, your all India live ranking is changing. And after completion of these things, we provide a detailed video solutions to you. This is very helpful to the student, very helpful or useful to the student. In this case, okay, after completion of the exam, you are going to be not perfect at some of the topics. That means you are unable to answer few of the questions. Okay, you can enhance that capability. That means you can get the solutions of that in a detailed video solutions. So from that, you can gain the knowledge of those topics also. Okay, and don't forget to use my code VROUT10. Next, see, this is the enrollment guide which is useful to you to get the scholarship test. First, enroll for free from your Android mobile. Next, appear live for the test. First, register, enroll, after that appear the test. Now you get the, after completion of the test, you get the video solutions. Follow that video solutions, practice it more and do it every week. Now if you follow 3 to 4 weeks, every week 20 model questions, 20 into 3 or 20 into 4, 60 to 80 different model questions you get, and from that you can win the scholarships. Okay, this is the procedure you need to follow to win the scholarship. Now see here, a Master Blaster practice series is going on. This is a free special class series. A free special class series is going to be conducting. In that 10,000 practice questions. 10,000 practice questions for GATE. You believe it or not, 10,000 10K practice questions for GATE. It was curated by top educators at an academy. Okay, so Master Blaster practice series is going on. It is a a free special class series. Don't forget that. 10,000 questions. So this is for computer science, electrical, electronics and communication students, mechanical engineering, civil engineering and chemical engineering. Now don't forget to use my code VIRAO10 to join for free. Now see, these are the different batches going on at present. There is a ascend batch for GATE 2023 for electronics and communication engineering students is going to be started just now. This batch was started from 12th May 2021. 12th May 2021. And don't forget to use my code VIRAO10 during subscription to get 10% discount. Here are the top educators who are handling the subjects in that. Now there is again ascend batch for GATE 2023. This time this is for electrical engineering, and it was also started from May 12th. And don't forget to use my code VIRAO10 during subscription. Next, there is a evolve batch for GATE 2022 for electronics and communication engineering students. Now it was started on 12th May 2021. And don't forget to use my code VIRAO10 during subscription. Okay. Now see, there is a new batches going on for RSEB, UPR, VUNL and for state AE exams. All these are for electrical departments. These are the booster batches. Here are the top educators who are going to handling the subjects in this. And this batch is going to start from 19th May 2021. And don't forget to use my code VIRAO10 to get 10% discount. So our today's session is on common gate stage. Okay, now common gate stage. Now here I am going to using MOSFET amplifier. Okay. So common gate stage. Okay, now first I am going to writing the circuit for this. VDD. This is the point where I am taking output. This is a biasing voltage you are providing. Okay, by using R1 and R2 you are providing a sufficient biasing voltage, and here you are applying input voltage. This is the drain resistance RD. Here VB is biasing voltage. Biasing voltage. Okay, now we are applying input at source terminal. Okay, now what happens if I change a small change at input side, small change at input, how it is reflected at output? See, let us, input rises by a small value delta V. Now let input rises by a small value delta V. Then what happens? See, input is increasing. Once input is increasing, in this sense voltage at source is going to be increasing. Once voltage at source is increasing, VGS is going to decreasing. Therefore VGS is decreasing. VGS is decreasing. Okay, so gate to source voltage is decreasing by same amount. Once VGS is decreasing, here our ID value is GM into VGS. So your ID value also decreases by the same amount. So ID also decreases by the ID also lowering or decreases. Okay, and it is lower by a drain current of GM into TV. This much amount it is going to be changing. Okay, now it results your output is going to be, then once the voltage drop across this is going to be decreasing, now the output voltage is going to be increasing. Okay, now output is increased by amount of GM into delta V into RD. Okay, this is the things takes place in this. So once you are increasing a small change in input side, now your VGS is going to be decreased by an amount of same delta V. Now once it is decreased by the amount of this, now your ID is going to be increase. ID is going to be increase. Now once ID decreases, ID also decrease, your ID is going to decrease. So once ID decreasing, the drop across this is going to be decreasing. Drop voltage VRD, voltage drop across this is decreasing. Once voltage drop across this is decreasing, voltage at this point is increasing, output voltage is increasing. Okay, so now finally it is increased by this much amount. Therefore output voltage is GM into delta V into RD, change in output. Okay, so change in output by change in input, it is the voltage gain, that is GM into RD. Now, or you can follow the same procedure also to calculate the voltage gain. Now first I am calculating the voltage gain of this. Voltage gain. From this analysis we got change in output is GM into change in input into RD. That change in output by change in input is nothing but a voltage gain, that is GM into RD from previous analysis. Now if you want you can take the regular procedure also. This is our common gate stage. Here we have input, here we have input, here taking output, RD is VDD. Now just replace the small signal equivalent of this. Okay, now it is the gate, it is the source, GM VGS, and it is the drain. From drain it is connected to ground RD, and we are taking at this drain point, output at drain. Now this is the VGS, source side. At source you are connecting the input and gate connected to output. Okay, this is your setup. Okay sir, now see, from this we can write this is GM VGS, this is your ID, now this is your minus ID. we can write output is minus ID into RD. Okay, so output is, now I am going to copying this circuit. So here I am taking RD0, RD infinity, sir. That means lambda 0, channel length modulation I am omitting. What are the channel length modulation here you have? I am going to be omitting that. Okay. Now here, so we taken lambda 0. From this output voltage we can write minus ID into RD, but ID is GMVGS, minus GMVGS into RD, that is your output. Next, this is your input voltage, but input is nothing but a minus VGS. Your input is nothing but a minus VGS. Just to substitute that values. Therefore, V output is minus GM into minus V input into RD. Therefore, V output by V input is GM into RD. Therefore, voltage gain is GM into RD. See, here just I applied small signal equivalent I taken. Okay, I done the analysis on that, not more than that. Clear? So next, I am going to calculating the input impedance RI. Input impedance. Input impedance. Input impedance. Take the same circuit. RD, it is biasing voltage VB. This is the impedance I want to calculate. Here I want to calculate input impedance. Okay, for that I am going to replacing this one by its small signal equivalent as usual. Previous case, gate connected to ground. Here is VGS. This is the source. Drain RD. This is GMVGS. To calculate the input impedance, here just connect a dummy source. A dummy source I am going to be connecting. Let us take it as Vx, and current entering into this is Ix. Now input impedance is simply Vx by Ix. Now get the value of this Ix. See, this current entering into this side is 0. Now this is the current. Total current Ix is entering into this. Ix is nothing but a GMVGS. Ix is, sorry, minus GMVGS. Ix is minus GMVGS from this. Therefore, from this Ix is GMVGS minus of. But you are saying it is VGS plus minus VGS, but it is grounded. It is also grounded. Now your Vx is nothing but a minus VGS. So Vx is minus VGS. Therefore, Ix is equal to minus GM into minus Vx. From that, Ix is GM into Vx. Therefore input impedance is Vx by Ix, which is 1 by Gm. So the input impedance of this one is 1 by Gm. 1 by Gm. Okay. Same way I am going to calculating its output impedance. So this is our circuit. Now I am going to calculating output impedance. Output impedance. So here is input voltage. Now I am replacing MOSFET as usual by its small signal equivalent. So without load we need to calculate it. First, gate, VGS, it is source, GM VGS, it is the drain, and here source is to calculate the output impedance, source has to be connected to ground. At the same time, first of all, your gate connected to ground. Here is your output impedance, R out. It is the output impedance of the device. Don't forget that output impedance of the device. With biasing resistors, that is the final output impedance. Let us take R output, which is the voltage between these two is VDS. VDS by, let us take this current is ID. ID at a condition of V input equal to 0. So here we are connecting input, V input. Now it should be connected to ground. Once it is grounded, VGS equal to 0. So once VGS is 0, from this your ID is, you can write GM VGS. So it is GM into VGS 0, which is 0, ID is 0. Therefore our output is VDS by 0, which is infinity. Output impedance is infinity. But the output impedance of common gate stage is including the RD biasing resistor, drain resistor. This is the final output impedance. This is R output dash. This is what we need now. Therefore R output dash is R output, what you calculated between these 2 points. What you calculated between these two, parallel with RD. Parallel with RD. So this is simply, it is infinity and it is a capital RD. So capital RD. So the output impedance of this common gate stage is RD. Output impedance of this common gate stage is RD. Okay. Next one. So far we calculated the voltage gain, input impedance and output impedance. Okay. And you observed one thing. So far whatever the analysis we done on this common gate stage, okay, we take only input voltage. That means there is no source we added. For example, there is some finite source impedance is present in that. Okay, we assume that. That means some RS I am connecting at source. Okay, with that RS, how can we analyze this? Now we check on this. Now Now it is common gate stage with finite source impedance. Common gate stage with finite source impedance. With finite source impedance. Okay, so now your stage is like this. VDD as usual, RD taking output from drain at a gate biasing voltage. In previous case we connected input here, but now I am connecting input here through finite source resistance. Finite source resistance. Now here it is input. That is the common gate stage with the finite source impedance. Okay. Now we need to analyze this. Just you try to solve once. Just try to calculate the gate voltage gain of this circuit. Try yourself. Now, first of all, let us take one thing. Already we calculated. Let us take if it is Vx. Okay, this part of the circuit already we analyzed. Already we analyzed this part of the circuit. We know the voltage gain of this. No need to replace again your complete device with a small signal equivalent like that. Whatever the portion you know already analyzed, you completed your analysis, just go through from that point. Okay, now we know V output by Vx is Gm into Rd. This is the portion we know it. But voltage gain of this overall is V output by Vx. V output by V input for this. Now I am writing that one as V output by Vx into Vx by V input. So V output by Vx, already we know that it is Gm into Rd. Gm into Rd into Vx by V input. Now you need to calculate Vx by V input value. And for my analysis, what I am doing is, whatever the impedance it provides in this direction is going to be, I know it, provides the impedance in this case, that is input impedance Rin. This total part is going to provide input impedance of Rin. Okay, now I am going to replacing this portion with that. Now say this. Now this is I am taking the equivalent of this is like this. Input side Vi, V input. After that it is Rs, and this is the voltage Vx. and impedance this side is 1 by GM. Already we know that this impedance is RE, that is 1 by GM. Now I am replacing this like this. RS 1 by GM. It is the voltage Vx. Now I am applying voltage division on this. Therefore Vx is V input into 1 by GM by 1 by GM plus RS, which is V input by 1 plus GM into RS. That is the Vx value. We need V input, Vx by V input. Vx by V input is 1 by 1 plus GM into RS. Therefore, overall voltage gain is GM into RD into this value, 1 by 1 plus GM into RS. So which is GM into RD divided by 1 plus GM into RS. So by with finite input impedance at source resistance is going to decrease the voltage gain. Okay. Now you observed it or not, the voltage gain what you get is this is the voltage gain you got finally, GM into RD by 1 plus GM into RS. You observed it or not, this is the voltage gain equal to the magnitude of the voltage gain equal to the common source stage with the degenerative resistor RS at source. Okay. So it is equal to the magnitude of the gain gain of CS stage with degenerative resistor RS. Degenerative resistor RS. That is the gain. Okay. So this is the value of voltage gain for this. Okay. Now I am going to calculating the output impedance or not. Output impedance. Output impedance. Output impedance. Okay, now this is our circuit. RS input. It is VDD RD. We need to calculate output impedance. Okay, output impedance means impedance in this direction parallel with impedance in this direction. By taking this one to ground and this input also connected to ground to calculate output impedance. Okay, we know the impedance from this point to ground is RD. This is RD, no doubt at all. Now need to calculate the impedance in this direction. Let us, I am going to calling it as Rx. After calling this Rx, getting this Rx, your output impedance is going to be Rx parallel with RD. Rx parallel with RD. After that, you get this. R output is Rx parallel with RD. Okay. Now, I am going to calculating the Rx value. To calculate Rx, V input should be connected to ground. Okay. Now I am going to copying that part of the circuit. So this is Rx. Rx. Okay. So this is our drain terminal. So this is Rx. Now we need to calculate the value of this Rx resistance in this direction. For that biasing voltage what you have should also be connected to ground. Okay, now I am going to copying this. Now replace your MOSFET by its small signal equivalent. Gate source VGS GMVGS, and we have, let us take lambda not equal to 0 because already we are adding finite resistance at source. Okay, you can consider this all not also, then you get the detailed value. So it is very useful by using considering R naught. Source, it is a drain. Okay, we need the resistance in this direction, Rx. Now to get Rx, connect a dummy source Px and that current is Ix, and source also connected to ground through Rs. Okay. Now Rx is Vx by Ix. Say careful. So once this gate connected to ground, here gate connected to ground, now gate connected to ground, the drop across this became V minus VGS, and the same Ix is flowing into this also, flowing through this one also, same Ix. But in case of this R naught, the current is Ix minus GMVGS. Ix minus GMVGS current is flowing through this. Now applying KVL to this loop, applying KVL to this loop. So applying KVL, now you get Vx equal to Ix minus GMVGS into small r naught plus Ix into Rs. And from this we can write VGS is minus Ix into Rs. Just substitute VGS this value in this. Therefore Vx is Ix minus Gm into VGS is minus Ix Rs into R naught plus Ix into Rs. Therefore Vx is Ix times R naught plus Gm into R naught into Rs plus Rs. So now we can write Vx by Ix is R naught plus 1 plus Gm into R naught into Rs. This is our Rx value. Okay, that is our Rx value. Once you know the value of Rx, therefore we got Rx is R naught plus 1 plus Gm into R naught into Rs. Okay, now Gm into R naught is much greater than 1. Therefore Rx is R naught plus Gm into R naught into Rs. Clear? That is the output resistance. Okay. Now final output resistance is whatever the RD we have, that RD parallel with Rx. RD parallel with Rx. So that is RD parallel with small r naught plus Gm into R naught Rs. That is the output resistance. Clear? Next. Now based on this knowledge what we gained so far, we solve a problems on this. Okay. Now let us take a problem. Whatever the stage we used previously, this is the stage, this is the problem. Already you are familiar with this. It is RD, VDD, biasing voltage and taking output. This is the circuit you are familiar so far. Let us take the point X. We are familiar up to this. Now my additional part, what I am adding to this is a diode connected device I am going to be connecting. Whenever source and drain are shorted, it behaves like a diode connected device. We call it as a diode connected device, and RS also. Input. Now for better understanding purpose, I am giving some name to that device, each device, M1 and M2. M1 and M2. Okay, M1 and M2. See, so I want to calculate its gain and output impedance. See, for that we know M2 is a diode connected device. diode connected device. It is connected from point X. Now if you take that point, that device like this is the point X. Only I am going to highlighting this portion. It can be replaced by its impedance. It is going to provide 1 by GM2. Already we done this analysis, sir. Otherwise do it once again, no problem. I want impedance at this point in this direction. Now gate plus minus VGS, it is source, drain, GMVGS, it is a drain. So drain and gate both are shorted. Drain and gate both are shorted and source connected to ground. Okay, this is a drain. In this direction, just connect IX, VX. So here IX, the current from this side is 0. That's why no use of it. Now here Ix is equal to GMVGS. Ix equal to GMVGS. Okay. But here Vx is nothing but a voltage at this point with respect to ground. Voltage at this point with respect to ground is nothing but a voltage at this point is nothing but a voltage at this point. VGS. So here VGS is nothing but a Vx. By substituting that, just to substitute that, therefore Ix is Gm into VGS, which is Gm into Vx. It is Ix. Therefore Vx by Ix is 1 by Gm. That's it. So a diode connected device is going to provide a impedance or resistance of 1 by Gm. This is a M2 device. Because of that I taken it as 1 by Gm2. Now replace this M2 by its 1 by Gm2. So I am doing the same. Just I am copying the device, not more than. Yeah. See this? Here you are taking output. This is biasing voltage. Now the next level of the circuit is now see this? Here I am going to replacing this. This is your X. So here I am replacing that one by 1 by Gm2. After that, just I am adding RS and V input. Okay, Rn and V input, and Now I am going to replacing this total by its impedance. Already we know the impedance this direction, that is here input impedance of this one is in this direction. We know that it is 1 by GM1 as usual. Already we calculated that also, because this is a device M1, that's why I am taking GM1. Okay, now it can be replaced by now it is like this. This is RS, it is X. Now from X to here we have 1 by GM1. This is the X. Okay, now copy this part, because already we know V naught by, we know one thing, we know V output by Vx value, that is GM into RD. Just I am following that. Now see from this is now written by like this. Here is input RS 1 by GM1 parallel with 1 by GM2. This is the voltage Vx. So which is one by GM1 parallel with 1 by GM2. Here taking Vx, it is RS and it is V input. Okay, now our intention is to calculate voltage gain. So voltage gain of this one is V output by V input for whole circuit. Now I am going to splitting that. It is V output by V input. So V output by Vx into Vx by V input. So now it is V output by Vx is, we know that it is GM into RD. Next we need Vx by V input. So from this I am writing Vx is V input into 1 by GM1 parallel with 1 by GM2 divided by RS plus 1 by GM1 plus 1 by GM2. 1 by GM2. Okay, now get the value. Therefore from this get the value and substitute here. Therefore Vx by V input is 1 by GM1 parallel with 1 by GM2 divided by RS plus 1 by GM1 plus 1 by GM2, sorry, 1 by GM parallel with 1 by GM2. Sorry, it is parallel combination, sir. First calculate 1 by GM2, GM1 parallel with 1 by GM2 divided by 1 by GM1 plus 1 by GM2. This is 1 by GM1 parallel with 1 by GM2. Okay, so now it is 1 by GM1 plus GM2. Okay, 1 by GM1 parallel with 1 by GM1 plus GM2. Now substitute that one here. Therefore, Vx by V input is 1 by GM1 plus GM2 divided by Rs plus 1 by GM1 plus GM2. So which is 1 by 1 plus Rs into GM1 plus GM2. This is the final value of Vx by V input. Take this, substitute in that. Therefore, gain is V output by V input, which is Gm into Rd into 1 by 1 plus Rs into 1 Gm1 plus Gm2. Okay, just to substitute the values in that. Sorry, output by here is Gm1 sir, because the device number we given as 1 M1, so Gm1. Therefore, gain AV is Gm1 into Rd by 1 plus Rs into Gm1 plus Gm. That's it. That is the voltage gain. Okay, so far we calculated the voltage gain of that. Once you know the voltage gain, next go and calculate the output impedance. Okay. Next, output impedance. First I am taking the circuit. Says it is Rs. Now it is very easy, very simple to calculate. For my easy purpose, I am taking it is V input. Now I want to calculate output impedance. This is output impedance, which is the parallel combination of this one and this one. Let us take it as Rx and take it as this is Rd, because it is connected to ground and input also connected to ground. At the same time, we know the equivalent impedance of this one. It is 1 by Gm2, and this is a device M1, it is M2. This is 1 by Gm2, 1 by Gm2. So first I am going to calculating the Rx value. Okay, so for that I am copying this circuit. So first I am calculating Rx. This is Rx. Now we can write this is equal to Rs this is 1 by Gm2. This is grounded because It should be ground biasing voltage. So we need this. This is your Rx. Okay, these two are parallel. I am copying this. Now, in this circuit, it is equal to Rs parallel with GM2 with 1 by GM2. Now, this is nothing but a common gate stage with resistor with finite source resistance. Already we calculated the output impedance of that. Okay, already we calculated the output impedance of that, and see, we know see if it is Rs and this is a device M1, and we know the value of Rx from a common gate, that is approximately R01, this one of device, this one plus 1 plus GM into GM1 into R01 into Rs. But GM1 into R01 is greater than 1, so we can write it as approximately R01 plus GM1 into R01 into Rs. Okay, let us take a device, later we add it, substitute. This is just for reference purpose, sir. This is just for reference purpose. Yeah, the same way, instead of here you have, instead of Rs you have Rs parallel with 1 by GM2. Okay, just use that. And at the same time here I am going to we are considering the output impedance of this one also. Now we can write it. And one more thing, once you are going to consider output impedance, you need to write this circuit by parallel combination of R02, because by omitting this we calculated this. Now we are considering R0 to this, that means lambda not equal to 0. For lambda not equal to 0, this is the case. Now here it became parallel with R02. This is the case. Okay, now so finally Rx is the same way, R01 plus 1 plus GM1 into R01 into Rs, that means this resistance, Rs parallel with 1 by GM2 parallel with R0, simple. Okay, it's very simple. Now if you observe, R0 is much greater compared to this, clear? So R02 is much greater compared to Rs parallel with 1 by GM2. Now we can write this equation by, therefore Rx is R01 plus, so compared to 1 plus GM1, you can take approximately GM1 into R01. So GM1 into R01 into RS parallel with 1 by GM2. This is the Rx. Now we need R output. Therefore R output is RD parallel with Rx. RD parallel with Rx. This is the way to calculate output impedance. Okay. Way to calculate output impedance. Next. So this is about your common gate stage. So first we analyze the basic common gate stage. After that we added a finite input impedance to that source terminal, and after that we take the little bit complicated circuit. At a source terminal we added, in addition to that finite source resistance, we added a diode connected device and we analyzed that one. Okay, once you are thorough with the basic device analysis, basic system analysis, now even though some additional components are added to that, by using a little bit simplification techniques, you can get the everything. Okay, now here are the top educators from an academy. Tiwari sir, he is IIT topper, having 7 years of GATE and ESE teaching experience, and he is the author of the book GATE in 75 days, and he belongs to mechanical engineering. Ankit Goyal sir obtained All India first rank twice in GATE electrical, and he was awarded President of India Gold Medal in IIT Indore. He teaches the electrical and electronics engineering. Sanchit Jain sir, he is the computer science faculty, having a teaching experience of more than 8 years. And Jaspal Singh sir, he is the ex-IAS officer. He got All India 4th rank in that IAS, and he is a scientist, GATE, state service exams and PSU topper, and he is the ex-senior MEDESE faculty. He has more than 12 years of teaching experience. Because of all these things, we are claiming that our educators are the top educators. Our educators are the top educators. IIT topper, gold medalist, IIT gold medalist, All India GATE topper, IAS ranker, All India 4th rank, well experienced faculty. By combining all this, we are saying that our educators are the top educators. Here are few more top educators. Here are few more. Now these are the different engineering disciplines available in GATE, available in an academy for GATE and engineering service exams. ECE, electronics and communication engineering, chemical engineering, mechanical engineering, computer science and IT department, instrumentation engineering, electrical engineering, civil engineering, production and industrial engineering, and mathematics and general aptitude is common for all the departments. And two plans we mentioned already, plus plan and iconic plan. In plus plan and iconic plan, both the case, India's best educators are handling your subjects. Interactive live classes are there, structured courses and PDFs, live tests and quizzes. But here in live tests and quizzes, we show the difference between plus subscription and iconic subscription. In iconic, once you've written the exam, it is forwarded to your personal coach. You do the personalized test analysis on that. Okay, and they prepare based on your performance in that, they prepare a proper study planner, and respect to study material also they provide. By following these two, every student can get success in their examinations. Now in plus plan, there are different subscriptions: 1 month subscription, 3 month subscription, 6 month subscription, 1 year subscription, 1.5 year subscription, and 2 year subscription. Don't forget to use my code VIRAO10 during subscription. By using my code, you get 10% discount. Okay, and one more important thing is, here it is available in EMI option also. Okay, see. So the beauty here is EMI option also available, and for iconic plan it is available in two subscription. It is available in two plans. Iconic plan, 1 year subscription and 2 year subscription, and here also EMI option is available. For 1 year it is 50,250 rupees. By using my code VROUT10 you get it by 10% discount. 10% discount, don't forget that. And here don't forget to use my code VROUT10 and hit the bell icon for getting notifications, and subscribe us, don't forget, and please give your valuable comments on YouTube. Join our Telegram group for getting latest updates on our upcoming videos. Thank you very much. Thanks for spending your valuable time with us.